Welcome to day 10 of me solving an algorithm per day, and today's algorithm is going to be electronics shop. Solve the challenge. A person wants to determine the most expensive computer keyboard and USB drive that can be purchased with a given budget. Given price lists for keyboard and USB drives and a budget, find the cost to buy them. If it is not possible to buy both items, return -1. Okay, so we want to buy both items and we're looking for the most expensive one. So that means adding both, and that should be the closest to the budget 60. Just thinking ahead. Keyboards 45 to 50, 60 and drives 5, 8, 12. The person can buy a 40 keyboard plus 12 USB drive, 42, or a 50 keyboard plus 8 USB drive, 58. Choose the latter as the more expensive option and return 58. Makes sense. Okay, that means should we basically loop over it and then add them to one another to know? We're basically returning, okay, the more expensive option and return 58. Function description. Complete the get money spent function in the editor. I think we have budget up until 1 million and N at M is smaller equal 1000. Okay. Well, interesting, because that means if the at max we can have 2000, right? Oh no, N and M are the okay, no, N space separated integers keyboards, the amount of keyboards and the amount of drives. So we have 1000 keyboards, 1000 drives at like worst. All right, and let's get to it. Let's see, we have a budget. We have keyboards, we have drives, and that means we could say keyboard and keyboards. Maybe there's something like, okay, we can sort by the most expensive. We can maybe even make a set, just in case there are duplicate numbers, right? So let's say set keyboard. We're just preparing our data so we are more efficient. Drives, just in case it's an edge case or something they do, and then we can filter out anything that's above the budget too, actually. That means set keyboards, filter out everything that's above the budget, because that will not end up filtered keyboards working. And then the same for drives. We can already make a filtered keyboards equal to 0, or right, if there's nothing that we can buy, filtered drives count equals 0, return -1, I think. So let's try for keyboard in filtered keyboard. You can say max or most expensive is filtered keyboard 0 plus filtered drives, first element. So that's the most expensive one. We're just assuming it in the beginning. So and then in the end we're returning most expensive. If for keyboard and then for drive in filtered drives, if keyboard, let's say sum keyboard plus drive, if sum is bigger than most expensive, then we want to say most expensive equals sum. Else it will just go Let's try that. Oh, error. Unresolved identifier. Okay. Let's just copy and paste because I'm missing an E there. Run it again. Filtered keyboards. Am I having what? Filtered. God damn it. Of course, filter it. Oops, not the wrong one. Filtered keyboard. Filtered. I'm doing the same mistake there too. Filtered drives, filtered. Okay, but now, come on. Oh, cannot get. Okay, well then we just say dot first. We know it's more than one element. So then we can use for some rep on first. Can use. So that one worked out. That one didn't. Your output -1, expected 9. When did I say? So we're saying standard input is 10, 2, 3 and 3, 1. Right? So N, M and B. How do I understand the input? By the second keyboard sample output 9. Oh, okay, so the budget is 10. The length is 2 and 3. That's what I'm thinking. And then we have keyboard and drives. And then it says the second and the third. So we are 9 and close to most expensive. We are filtering, right? And it's -1. So we're filtering, basically we have 3 and 1. It's 10. So that should not be true for a set of keyboards. That's a set of keyboards and 3 is not bigger than budget, right? Filter where this is true, right? Whoops, the other way around. The output is 11. Well, at least we have now probably returns where this is true. Okay, so we are here. And we get the first one, it's 3 and 5, which is 8. Oh, it has to be more expensive and sum is smaller equal B. Only then. That works, and now submit. And it failed for some cases. For some edge cases, it seems. We can spend thinking instead of using hackers. Although, I mean, what else are you spending hackers on if not unlocking some? Alright, it's truncated. Expected output is this one, but I'm putting out something else. 938, 177, 938, 168. Okay, let's print most expensive and see. Wow, wrong answer? Your output is 11. Why is it a wrong answer? For the local test even. Expected output 9, debug 11, okay. 9. What am I doing wrong? My output is 11. How is that even possible? Oh, because the first could be. Oh yeah, the first could be like, yeah, we can start at 0. Because then the sum is going to be. Yeah, what I'm thinking is the first keyboard and the first drive together, it could be beyond our budget. That could be an edge case that they thought of. Oh, what if he uses the first elements of both? God damn it, you got me. It runs a little bit too long. Let's do this trick and see. It says congratulations, but it also says didn't execute in the time limits. Does that count? I don't know. How am I supposed to maybe improve the looping? There might be a mathematical equation that makes it quicker. Did I get 15 points? I got all the points. All right, let's count it as solved. I mean, test case 0. I don't know. Test case 0 is even the local thing. I previously not fixed it, but ran within the time limits. Let's try again from here. So test case 0, submit. Oh, there's another test case 0. Okay, let's see from here. That looks better. All the test cases, and congratulations. Great, I am taking this. That's algorithm number 10. I hope you enjoyed the video. If you did, then hit like. If you want to leave a comment, do that down there, and subscribe to not miss out on tomorrow's algorithm. See you then.